what we did over here, like the wind is done, if you see the wind is very, you get small wind elements in the past in your farm, and slowly got bigger, right now having the megawatts in each one. We took the same example and we went in there, tried to make the system as large as possible, because those are very high efficiency, you have the smallest footprint. You make it very large, then you reduce your total installation cost drastically. So it's all this done in the factory. You ship it to the field, and all of a sudden you're putting 50 to 60 kilowatt in one pedestal, and it's very powerful stuff. So this is more example of this. This is shows, because we don't have lots of time, what other technologies do as far as the highest technology in different ones, where you have a cell. You make it from a cell efficiency all the way to the system, you lose quite a bit of power because you have losses, temperature, optical losses, everything else. And this graph somehow shows you for different technologies like crystalline technology or the thin film and something what happens. And this one over here, I'm showing this on because this particular technology that we have is perfect for for utility application, because most of the peaking power is right around afternoon when you have lots of air conditioning working and everything else. And this one, because it's tracking and is basically it matches that profile, and it shows the blue over there. It shows basically the electricity usage profile from, let's say, Southern California, Edison, what have you. The green one, this is where we see it's basically our component. The brown one underneath of it, and you have a blue one. The brown one is basically one-axis tracking, what it's called, and the other one is non-tracking. So you see that non-tracking on your rooftop fades away way earlier than you get your 3 o'clock, 4 o'clock. You're not generating as much and not contributing as much. This one is a profile of this particular technology, and it shows you from the early morning what we call the DNI, how the strength of the sun is direct, normal, incident, the power of it, and it shows you how much you're generating at that day, and it shows you what the efficiency is. As you see, the whole system, that the 2 wires coming out of it, AC wires at 280 volts, whatever, is basically, it is 25% efficiency. It means that you're converting 1/4 of the sunlight into direct electricity, that's useful electricity. I think, so I got a little bit more into this, the carbon footprint, because this is, as you make renewable, and carbon footprint of renewables is very important. This is a big subject, and people trade in the carbon, do this, do that. And this particular instrument is really one of the lowest carbon generating or thing, because the payback is very quick on it, and with the material that you make, the steel and things, but don't use as much electric power to make it. This is showing an example in our factory, what we call a mega module. Okay, the mega module is, as I said, is 10 kilowatt, big, huge module. We made it that fits in the back of a truck. It's as wide as long as a big truck, and we stack 4 of them on top of each other, and we take them to the field. In the field, you lift it with a crane, and you deposit it on top of what we call a torque tube, and a moving element that has a head that's moving. And so in here, let me see this one, how it works. There was a little video, but forget it because we don't have time. And the other thing I want to emphasize about this technology, because it's mounted on pedestal, you don't disturb the environment. Because you put a hole like 3-4 feet in there, you put this pedestal in there, all around it, like you see in this case, this is in Spain, and the animals are grazing around it and shading and everything else, and this moving all around during the day, so they don't kill, because lots of technologies right now, the flat plates, what we call it, it sits on the ground or something, and the shade underneath of it and kills everything underneath, and the animals. This way, you don't have any of that problem, and it's very important for the news. This is showing more, lots of people about the cell used in this one. We call it multi-junction solar cells that Dr. Kevork can touch upon. And what it does, Billy, and here I'm showing the spectrum of the sun. It's, as he said, most of the devices that's made today, whether it's a thin film, copper indium desalinate, or telluride, or silicon crystalline, or non-crystalline silicon, they all only see what we see. Okay? The rest of it filters it out. So it doesn't absorb the spectrum that is absorbed approximately what we see. What is like Dr. Kevorkian said, there's a lot of energy all around it. And so how you harness that. And people made for a space application that we long time ago we worked on and saying to make energy maximum for satellite. So now we brought that technology down to Earth and using it for commercial application. It's basically what it is. You go into the UV region and you go into what we call the red region. We put that all together, all of a sudden boost the efficiency because you have that energy you weren't harnessing before. All of a sudden you have efficiency of 40%. Now today, and they promise to go to 45 to 50% in the near future. So that's why you could make 2 junction, 3 junction, 4 junction, and most of you, a lot of engineers, but when you make too many junctions, all of a sudden they don't start talking to each other. So today's limit is 3, but you could make them more together. So I'll go through, and this shows it's one of this, what we call the modules. What the I showed you earlier, the square one, that's about 1 meter square. It's doing basically almost 300 watts of power and 32% efficiency. This is we just submitted this to NREL for the record-breaking highest efficiency solar module in the world. Okay, this is a big field in Navarra, Spain, and it has a 560 of those systems and generate about 8 megawatts of power. And this one of our engineers has this Tesla I put over there for the scale. It's very huge, this university of Nevada. There's more of them in what SNW, Southern Nevada Water Authority. That's the place where Barack Obama and Harry Reid came in and they gave us the award or whatever. So because the first of its type that we installed in there. So basically, what I say, because of all this attribute, which is basically low LCOE and very high efficiency, very easy to deploy, and very easy to expand on, and the low cost of the capital needed to do it, all these things, we believe this technology will be the future, and we're going to what we call terawatts. It's a gigawatt, and you're going to terawatt of technology, exactly, and that's the end of it. Thank you.
Thank you, Vahan. It was a very interesting topic. Just give me a moment to load up the next one.